Hello and welcome to our lesson on radical expressions, conjugates. First, let's talk about definition. A radical expression, no equal sign, combines numbers, variables, and radicals with an operation. So it could have a plus, subtraction, multiplication, division sign, but like I said, no equal sign. A new expression that's created when you flip the sign between two algebraic terms is called the conjugate. So if I have x plus 3, the conjugate of it would be x minus 3. Notice that I kept the x's exactly the same. I kept the numbers the same. The only thing that changed was the sign that connected the two of them. So let's take a look. I've got 5x radical 3, negative 2x radical 4. What happened when I changed it? 5x radical 3, exactly the same. 2x radical 4, 2x radical 4, the same, and here's the difference. This was what made it a conjugate. It went from a negative to a positive in between the two terms. So if I have x squared and then 54y to the fourth, and we're looking for the square root, same thing as over here, they both match. Then I have 5x squared times the square root of 21y to the third, okay, and 5x squared times 21y to the third. They match. The only difference between the two is I had to add them in one of them, and I subtracted in the other. And it's because of that sign flip in between the exact same terms that causes it to be a conjugate. Now, when do you use these things? Well, if an expression on the denominator of a fraction is not rational, when it's not rational, it means there's a radical down there. Then you will have to use multiplication to make it rational. And the way that you do this, in other words, with all these fancy words, the way that you get rid of a radical on the denominator during an expression is you multiply by the conjugate. Same exact terms, flip the sign. Remember, only the sign between the terms flips. Everything else stays exactly the same. So let's take a look. Here, if I start with this, and I need to find the conjugate of the denominator, that means I would multiply it by 3x plus the square root of 54. I just multiplied it by its conjugate. Same 3x, same radical 54. The sign was the only thing that changed in between the two of them. And when you're multiplying to change a fraction, you remember equality, whatever you do on the top, you got to do on the bottom. Whatever you do with the bottom, you have to do on the top. So we would multiply it like that. But down here, in order to create the conjugate, we're going to rewrite the term 9.5x. We're going to rewrite the term radical 7y to the ninth. And instead of a plus sign, we're going to put a subtraction sign. We just created the conjugate. And then we'd have to multiply the numerator by the exact same expression. And now we've created the conjugate of the denominator. So what happens when you multiply the denominator by the conjugate? Well, for this one right here, that is not a rational expression because we've got a radical on the denominator. Can't be there. So to get rid of it, you're going to multiply it by the conjugate. Remember, same terms, just different sign. You've got a negative here, and this time it's going to go positive. Now, equality with the fractions, whatever you do to the denominator, you have to do the same thing to the numerator. So we're going to multiply it by that same conjugate. And here, when you're multiplying, you multiply like terms. So 3x times 3x is 9x squared. So far, so good. But what you need to do for the rest of it is a FOIL. If you remember FOIL, you're multiplying the first, then you're multiplying the outside. So 3x times radical 54. It's right here. Then you're going to do the inside, which is negative 54 times 3x. It's this one right here. So I have this, this one, and then the last one is going to be the 54 times the 54, and that's my last term. Here, I'm just distributing the 2x to each of these terms. So I'm going to end up with 6x squared plus 2x radical 54. That's what would happen if we're trying to rationalize the denominator. Look what happens to the two middle terms, the O and the I. Do you notice something about these terms? What's going to happen? They look exactly the same except for one thing. One is a negative and one is a positive. Well, if you have a negative of something and you add the exact same thing onto it, what's going to happen to it? It cancels itself out. And look what happens to the last term. It's radical 2916. So, if we take radical 2916, and it's a big one, so instead of doing a factor tree, just punch it into the calculator, and it turns out that it equals 54. On the bottom, we're going to end up with that lovely 9x squared minus 3x radical 54 plus 3x radical 54. And then you're going to have minus radical 2916. Now we just said that 3x radical 54, the negative and the positive one together, cancel each other out. And this right here turns out to be a positive 54. So what we just did on the denominator was we got rid of all the radicals. And what we're left with on the denominator is 9x squared minus 54. Not bad. And on the numerator, you have a little bit more left over. You have the 6x squared plus 2x radical 54. Does it matter if you have a radical in the numerator? No. That doesn't make it rational or irrational. What makes something irrational is if the radical is on the bottom. Since we got rid of it, we now have a rational expression. At this point, you could go ahead and factor out a 9 from the denominator. You could factor out a 2 from the numerator. You could reduce, take the 54 down to the prime factors, all of that. But all we really wanted to show you right now is that you can rationalize a denominator by using the conjugate. And the conjugate is the same exact terms with a sign flip in between. Conjugate means you keep the same numbers and variables but flip the sign in between the two terms. Multiplying the conjugate removes the radical in the denominator, and we just saw that. The first term is squared. The second term and the third term cancel out, and then that fourth term goes back to the original number that it was without the radical sign. So when you square a radical sign, it cancels out the radical sign. That's the whole purpose of doing that to the denominator. Get rid of all those radical signs. And that's it for our lesson on radical expressions, conjugates.